Hey, Platform Con. Hope you're all enjoying the amazing talks and workshops. I'm Nicky McCrea. I live in Belfast with my wife Hannah, our son Freddie, and our golden lab Dennis. When I'm not out walking Dennis or chasing after Freddie, I'm a software engineer at Cloudsmith. And today I'm here to talk about powering your packages at lightning speed, artifact management unleashed. So, who are Cloudsmith and what do we actually do? Well, Cloudsmith is a fully managed platform for storing and distributing software packages, from Docker images to Python whales to Ruby gems and everything in between. It provides a single place to host your own packages and also proxy third party ones, with built in features like caching, access control, and policy enforcement. The platform itself is designed to remove the complexity of running your own package infrastructure, helping teams reliably manage and deliver packages at scale, with security and performance built in from the ground up. But that's just the backdrop. What I really want to talk about today is performance, specifically how we've built our platform to deliver packages from public registries quickly and reliably, even when working with a wide variety of package managers and upstream sources. Now, let's be honest, we've all been there. We've seen the memes, sitting through a CI run that drags on forever, wondering, why is this taking so long? It's taking us hours to deploy anything. And while there are plenty of obvious culprits, could be misconfigured pipelines, flaky tests, oversized containers, one we often overlook is the package registry itself. It's easy to overlook, but dependency fetching and indexing can have a huge impact on build times, reliability, and developer experience. And that's what we've been focusing on at Cloudsmith. And in this talk, I want to walk you through what we've learned, what we've built, and what's worked for us. So, here's what we're going to cover today. First off, we'll walk through how package managers interact with registries at a high level, how Cloudsmith integrates public registries through our upstream feature, how our indexing approaches ahead of time versus just in time can make a big difference to performance, and how caching isn't just about speed, but also helps with things like policy enforcement and security scanning. So, before we dive into upstreams, it's probably worth taking a step back and covering some of the basics, how package installation actually works under the hood. So you've got a package client on the left here, and that could be something like npm, pip, poetry, or pub. And these are what developers use day to day to install packages. And those tools need to know where to get the packages from, right? That might be a public package registry like PyPI or npmjs.org, or it could be a private one like Cloudsmith. And once that connection's made, the tool fetches metadata, pulls down the package, and installs it into your environment. That's the flow. And it's important to understand because upstreams fit right into the middle of that. It's also worth noting that package clients typically make two types of requests to a registry. I would call them info requests, and these ask what's available, what's in this package, things like index requests or fetching package metadata. The second type is download requests. These are the send me the actual thing operations, the retrieving the package binary itself. From a performance point of view, it's often the info requests that can become a hidden bottleneck. They're small, they're frequent, and they often fly under the radar, but they add up fast. And none of this changes when we introduce an upstream. So at Cloudsmith, we support something called upstreams, right? I've said it a few times. It's really our way of integrating public registries directly into your workflow. But what does that actually mean? Essentially, you point your package manager at Cloudsmith, and behind the scenes, we proxy the request to the public registry for you. Your client only ever talks to Cloudsmith, and we take care of the rest. So, is it really that simple? Just proxy the upstream response straight through to the client and call it a day? End of talk? We all good? Not quite. If we had to reach out to the upstream registry for every single request, things would get slow pretty quickly. We'd need to fetch metadata, sometimes from multiple different upstreams. We'd need to serve that back to the client, and then we'd need to do the same again for an actual package download. And then there's more at stake. We're completely reliant on the upstream being available and responsive. If the upstream registry is rate limiting requests or experiencing outages or just slow, that directly impacts our ability to serve packages. So the way we've tried to combat this is by storing upstream metadata locally. That way we can serve package info type requests directly from Cloudsmith without always having to go upstream. Under the hood, this relies on a process we call indexing. And over time, we've developed multiple strategies for how to do it efficiently and reliably. So let's talk about AOT indexing, or ahead of time indexing. It came out of a simple need. We wanted to make upstream package delivery feel as fast and predictable as if the packages were hosted locally, without relying on upstream availability every time a request came in. To make that possible, we run scheduled jobs that first fetch the upstream's index and then retrieve metadata for every available package. We store all of that locally in our database, versions, dependencies, all of it. That gives us full visibility into what exists upstream without needing to call out for it in real time. This matters because it solves a real world pain. We've felt it ourselves: slow builds, timeouts, inconsistent upstream performance. Now, when a client makes a request, we can respond instantly. If a package doesn't exist, we know that right away. No waiting on a 404 from the registry. The end result is a much more stable experience. Less reliance on the upstream, better failure modes, and builds that keep moving even when the upstreams don't. It's not about indexing for the sake of it, it's about keeping pipelines unblocked. This is our other approach to indexing, JIT, or just in time. This approach typically comes into play when AOT indexing isn't an option. Maybe the upstream doesn't expose an index API, or there's no clear way to traverse that full list of packages. Sometimes there's no canonical source of truth at all. In those cases, we have to build visibility as we go. Here's how it works. The first time a package is requested, we proxy that request straight through to the upstream. If the request succeeds, we trigger a signal that creates a database record for the subindex. From there, our subindexing task picks it up and begins regularly fetching metadata for that package, storing it locally. Then, the next time that same package is requested, we can serve the metadata directly. No need to reach upstream again. While this approach doesn't provide the immediate performance benefits of ahead of time indexing, it reduces upstream calls over time, improving responsiveness as the system learns and stores more package metadata. So as more packages get indexed locally, the issues we discussed earlier, like latency or reliance on upstream availability, are gradually minimized. It's a slower burn, but a practical solution when a full index isn't available. Now that we serve metadata directly from Cloudsmith, we can aggressively cache those info type requests, things like index lookups, package metadata, right at the CDN layer. These are the calls that package managers make constantly, often in the background, and caching them at the edge means they get handled in milliseconds without even touching our core services. That alone makes a huge difference in baseline performance, but it only solves part of the problem. Because what about the actual download itself? Here's the thing: we're not mirroring the upstream. We don't host those files ourselves. That means by default, a download request for a package that hasn't been seen before would require us to reach out to the upstream every single time. And that just doesn't cut it. Not if we care about speed or reliability. So we had to answer the question: how do we break that dependency? How do we avoid having to call out to the upstream for every download? That's what led us to upstream caching, a system we built to promote packages to first-class Cloudsmith assets the moment they're fetched. Right, so this one looks a wee bit more complex than the previous diagrams, but don't worry, I'll walk you through what's happening. When a package client makes a download request, it hits Cloudsmith first. We handle authentication and package lookup, then proxy the request to the upstream to fetch the actual package file itself. Once that download completes successfully, it triggers what we call an upstream caching event. Now, just to clarify, when we say caching, we don't mean temporarily holding on to the file. It's not in an ephemeral layer This is a one-time fetch that kicks off a background task in our upstream worker. That task retrieves the full package file, the actual binary, and stores it permanently as a Cloudsmith package. It becomes a first-class citizen in the repository, just like any other package you'd publish directly to Cloudsmith. So what does that actually mean for you? Well, it means that on the next download request for the same package, Cloudsmith serves it directly from your repository. No need to reach out to the upstream, resulting in faster downloads and greater reliability. Once the package is stored in Cloudsmith, we can do much more than just serve it quickly. We have more control. We can scan it for malware, enforce vulnerability and licensing policies, and surface any known issues, all without needing to contact the upstream again. Crucially, if we detect anything risky, we will automatically quarantine and block its download entirely, preventing vulnerable or non-compliant packages from reaching your developers and build pipelines. This approach takes the upstream out of the critical path. It unlocks powerful security and governance benefits. It's about knowing what's running through the system and having tools to act on it before it becomes a problem. So why does all this matter? If you zoom out from all the diagrams and detail and everything we've walked through so far, here's the core of it. These weren't abstract product decisions, they were practical engineering responses to real world challenges we were hitting again and again. We needed a way to deal with unreliable upstreams. We needed performance to be predictable and not dependent on registry uptime. We needed visibility into what was flowing through our systems so we could offer more than just proxying. We could offer control, insight, and security. That's what led us to build these things. That's what led us to build AOT indexing, JIT indexing, and upstream caching. Because we weren't going to build a platform that only worked when the upstream did. We wanted something resilient, something we could stand behind, something that felt fast, stable, and transparent, even when the source wasn't. And yet, if it just so happens that this makes life better for our customers and their pipelines too, then that's a win. Thank you for listening. I'd also like to invite you all to enter our contest for a chance to win a £250 GoGift gift card, redeemable at thousands of brands worldwide. The raffle is open until Friday, the 27th of June, and the winner will be notified on Monday, the 30th of June. Good luck, and thanks again for listening.